I love you.
What's up guys, Coach Sepi is here, and today we're going to be looking at simultaneous equations, specifically on how to solve them on graphs. Unlike last week's example where we were looking at simultaneous equations alone, we're given two equations and we have to solve for x and y. This week we're going to look at how to solve them graphically, so you guys get a much better understanding of how this works visually and not just from a theory perspective. Now, as you guys already know, simultaneous equations are two equations that intersect at a specific point on the graph, and this point has specific coordinates in terms of x and y in which we have to solve for. Now, in this specific example, I'm just giving you guys a brief idea of how it works visually, where it's two lines crossing each other, and let's say they cross at a point, for example, 2 and 3. And that's how we know they're simultaneous, because they're crossing each other at the same time. Now, through my experience in GCSE exam questions, I can tell you guys there will be about 2 to 3 specific general examples of questions that they will ask you about this topic. The first one is typically the graph is already given to you and they've already drawn both the lines and it already crosses at a specific point. And the graph will have markings on the sides of x and y, and you have to, through inspection, figure out what are the coordinates of that point, how far along is the point in terms of the x-axis, and how far along in terms of the y-axis, and this will enable you to get to the final answer. The second example is typically the graph is half drawn, so they will draw one line and then give you the equation of the other line and give you a table of values, and you will have to fill out those table of values and plot each point on the graph and connect those points all together to give you the second line, and that second line will cross the first line at a specific point, and then from there you can solve for inspection. The final example is the graph is given, however there are no markings and it is impossible for you to solve it for inspection. So you will just be given the graph, the two lines, the two equations of the lines, and you will just solve them. Now let's go through these in specific GCSE question so you guys get a better understanding of how this works. The first question is, you're given two equations, 3y plus 2x equals 12 and y equals x minus 1. And they've both already been drawn on for you on the grid in square spacing, which is very easy for you to inspect. We've already identified the point of intersection, and now it asks you use the graphs to solve the simultaneous equations. So the method you use for this is simply count how far along the point is in terms of the x-axis and how far along it is in terms of the y-axis, and that will be the coordinates of the point of intersection. We can see from this graph that it goes along 3 points in the x-axis and 2 points in the y-axis. So let's draw this up. And you can draw this from either side, either the right side or the left side. It's the same distances in terms of x and y. So horizontally it moves 3 and vertically it moves 2. Therefore the x coordinate must be 3 and the y coordinate must be 2. And we can double check if this answer is correct through substituting these values into either equation that is given to us. So we can sub in the x for the x and the y for the y. What happens now is we'll have 2 equals 3 minus 1, which is pretty trivial and is obviously true. So we know this is the correct point of coordinates. Let's move on to the second example. This time you're given a straight line, y plus 2x equals 5, and it's already been drawn on the grid for you. However, you can see that we don't have the second line. And this is just like that second general example that I told you guys about. We're going to have to draw the second line through the equation that we're given and the table of values that has been given to us. So the equation of the second line is y equals 2x minus 1. We have to complete the table of values. We can complete the table of values by substituting in the x values instead of the x that's already given to us. So for example, the first x value that is minus 1 in the table, we substitute it in for y equals 2 times x minus 1. We'll have y equals 2 times minus 1 minus 1, which will give us minus 3. And you can carry out this method for the next empty space, which is x equals 1. We'll have y equals 2 times 1 minus 1, which will give us 1. And you can see the pattern here that the points of the y are moving up 2 each. The next step we do is plot these points, these coordinates that we've solved and been given to us onto the graph. So the first point is minus 1, minus 3. So you go minus 1 along the x and minus 3 along the y. And that will be our first point. Mark the points on the graph, minus 3 in the y and minus 1 in the x, and we have our first point. You mark it there, and then you move on to the second point, which is 0, minus 1. Next point is 1, 1. Next point is 2, 3. And then you have your final 2 points. And now you can see there's a correlation, there's a positive correlation between the points. Now you can connect them by using a ruler and filling it out. And you can see that there is a specific point of intersection that we will get to in the next part of the question. So draw the second line and point out the point of intersection. We can see that the point of intersection goes along 1.5 in the x and 2 in the y. So we can draw this out. 1.5 in the x, 2 in the y. We can put this into the final part of the equation. And this is 6 marks, guys. So through that whole process, we got 6 marks, and we did it less than 6 minutes. So you can see that using this method is very quick and very simple. We substitute these in to either equation to verify that they're correct. And as you can see, 2 times 3 over 2 minus 1 is indeed 2. Let's move on to another example. This time we have 2 equations, but it's not on a grid, so we can't figure them out graphically. It says the diagram shows 2 straight lines intersecting at point A. Point A has x and y coordinates, so we use these 2 equations to equate them to each other because they both have y in common. So we cancel out the y's and we're left with 4x minus 8 equals 2x plus 3. We can collect like terms, move the x's to one side and the numbers to another side. So 4x minus 2x is 2x, and 3 plus 8 is 11. We can simplify this to get x equals 11 over 2. That's our x coordinate. And now we can substitute this x coordinate back into either equation. Let's substitute into the equation y equals 2x plus 3. We'll have y equals 2 times 11 over 2 plus 3, which is 11 plus 3, which is inevitably 14. And this is our point of intersection. These are the 2 coordinates. What's up, guys? Hope you found that video educational. Now if you want to completely transform your maths abilities and take it to the next level with both A-level and GCSE maths, I provide weekly one-on-one maths tutoring lessons on my Patreon, where I help you with any topic that you're struggling with in maths, and I coach you to completely transform your mindset when it comes to maths. So follow the link in the description for that. Check it out. Peace.